Welcome to What Are Exceptions? Errors in Python are called exceptions. When something goes wrong, dividing by zero, accessing a missing key, converting invalid input, Python raises an exception. If nothing catches it, your program terminates. Division by zero. Python raises a zero division error and stops. Trying to convert non-numeric text to an integer. Python raises a value error. Accessing an index that does not exist. Index error. Read the exception type and message, they tell you exactly what went wrong. The traceback shows which line caused it. Read tracebacks from the bottom up. Welcome to try except blocks. Try except is how you catch exceptions before they crash your program. You put the risky code in the try block. If an exception occurs, Python jumps to the except block instead of terminating. The try block contains code that might raise an exception. Risky operation. The user might type something that is not a number. Second risk. The user might enter 0. Catches only value error when the int conversion fails. Specific exceptions are better than catching everything. A second except for a different exception type. Each potential error gets its own clear response. Specific exception handling is a mark of quality code. It shows you understand exactly what can go wrong. Welcome to else and finally. The full try structure has 4 parts. Try and except you know. Else runs only when no exception occurred, the success path. Finally runs no matter what, ideal for cleanup. Attempt the conversion. Handle the failure case. Else runs only when try succeeded with no exceptions. This keeps success code out of the try block, which should contain only the risky operation. Finally runs whether an exception happened or not. Use it to close files, release connections, and clean up resources. The 4-part try structure makes exception handling complete. Else and finally are not used in every case, but when you need them, nothing else will do. Welcome to Common Patterns. Good error handling is a skill. Let's look at 3 patterns that appear in almost every real program: input validation loops, safe conversion helpers, and raising your own exceptions. Keep asking until valid input is given. A successful conversion breaks the loop. An invalid entry prints a message and loops again. Raise lets you signal an error from your own code. Provide a clear message explaining what was invalid and why. These patterns form the backbone of robust Python programs. Programs that handle errors gracefully feel professional. Programs that crash feel broken. If this lesson helped you, smash that like button and share it with a friend who's learning Python. Subscribe so you never miss a lesson. And continue your full learning journey for free at pylearn.saypeace.ng.